Hi all, hope all is well. On today's video, we will be continuing the solar distillation experiments. Now, if you're unfamiliar with the idea, basically the experiment entails taking seawater and distilling drinking water from it. So obviously you can't drink seawater as it is. You need to actually extract the drinking water from it, which leaves all the minerals and salts behind in the centered jar. So this footage you can see here is of a variation of the experiment. So this is an experiment that I've been doing for a couple of years. And there's a control unit, which is basically just a clean jar of seawater inside a larger jar. And the jars are left out in the sun to get exposed to the light and the heat. And what happens is the water evaporates from the center jar, and then during the night it condensates and runs down the inside of the larger jar, as you can see in this footage here. Now, the footage you're seeing here is actually of the variation. So we've been getting heaps of comments in the comment section, and I encourage that everyone participates. It's fantastic to be getting so many great ideas. And one of the ideas was to put charcoal or something black inside one of the jars. So we have a standard unit, which is just a control unit, just a basic solar distillation unit, as you see in this footage. And then the other unit has charcoal in it. And the idea is we could basically run both of the experiments together side by side to see which one would produce the best results. And to say the least, the results have been exceptionally astounding. So I wasn't expecting such a positive result from such a small variation, and that's exactly what we've gotten. So if you have a look there, obviously the variations on the right hand side with the black charcoal in it, there is quite a bit of water in that jar, which indicates that the procedure actually worked. So the process was actually sped up, and instead of getting the 12 ml of water over 3 days as we do with the standard variation, we were getting a lot more. And in the end, I believe it was about 150 ml, which is times by 12. It's 12 times the production rate by just making a simple change. Now, these results actually seem too good to be true, and I had my suspicions. And one of my suspicions was it was raining over the period of time that we did these experiments. So it was a period of 3 days, and during those 3 days, there was a little bit of rain. And I was thinking that perhaps one of the jars were leaking. So that's definitely a possibility, and I still can't quite rule that out just yet. So what I need to do is I'll rerun these experiments again. I'm actually going to swap the lids around because one of the lids was very loose fitting and the other was tighter. So the standard variation, the variation of the experiment that just has the seawater and no charcoal in it, has a very good seal in the lid. And the charcoal unit actually had a bit of a loose fitting lid. So I was suspecting that the water from the outside of the jar was making its way into the inside of the larger jar. However, we don't know that for certain just yet. The only way we're going to find that out is to actually rerun these experiments and just swap the lids. So we're going to take the lid from the charcoal unit and actually place it onto the standard unit. We'll take the standard unit's lid, the one that seals up better, and we'll place it onto the charcoal lid. And this is just a process of elimination. And if we see similar results in the next video, which will be released in the next couple of days, we know for certain then that the charcoal is actually improving the rate of evaporation in the variation jar. And surprisingly, I believe that this has in fact improved the results massively. It's not just a small amount. If the measurements are anything to go off, then it's quite a substantial improvement. And it's definitely a step in the right direction, because after all, that's the aim of these videos. These videos aren't just about educating people how to actually go about solar distillation. The process is pretty simple, as a lot of people have stated in the process. It's no different than having seawater out in the sun and evaporating during the day, and then during the night it gets condensated into clouds, and if it meets its dew point, or if there's enough moisture around, it will actually rain. You can't forget that the Earth is basically a jar. It has an atmosphere around it, It's floating through space, so it's isolated, and any moisture that is evaporated during the day on Earth is actually captured in the atmosphere, and then when the conditions are right, for example, when it meets its dew point, which is basically a variation between saturation point of the atmosphere and the temperature, then the moisture can drop out of it. It's similar to having a cold can of drink sitting on a countertop and having the warm atmosphere pass by it with moisture in it, and it actually dribbles down the side of the can. This experiment is exactly that. So here you can see that we've actually gone ahead, we've checked our variation there. So this is actually, yeah, it's got 30 mil in it, and this is from the standard variation. It was over a period of 3 days. So we did get some positive results from that. That's a decent amount of water from the standard variation. I do suspect that perhaps a bit of moisture was making its way in there, but there's only one way to be certain, and that's to actually run these experiments once again. So it's just a matter of going ahead, setting these back up at some point, and running them for a period of time. It doesn't matter how many days, whether we do it for 3 days or for 7 days, just as long as both of the experimental jars are being run for the same period of time. Now, if we got 30 mil from the standard variation, which is just a standard solar distillation unit, you can see that we have exceptionally more water in this unit here. So it's pretty obvious there that there's quite a bit more water in there. So it was just a matter of actually dismantling the unit. You can see there that that lid is very loose fitting. I do show a little bit of footage as well to show that there was possibly a fault with the unit. And again, like I say, the only way we're going to sort this out is by running these experiments once again. But at this stage here, basically it was just a matter of actually removing the lid and testing to see exactly how much water we had in the inner jar itself. So the idea is, for those who don't know, is basically including something black in the inner jar itself is to absorb a bit more heat from the light itself. And by keeping that heat up in that inner jar, we can actually increase our yield of evaporation from the inner jar. Once it's left the jar, the moisture is extremely hard to find its way back into the inner jar. It's basically like a water trap. Once it leaves that inner jar, it saturates the atmosphere around it, stuck in the jar, because the jars are sealed, or as close to sealed as possible. We could obviously seal them up a bit more if we wanted to, and I have in the past. However, I want to keep doing them with loose fitting lids for the time being. And as you can see there, once the water has left the inner jar, it gets trapped in the atmosphere of the larger jar, and then during the night, the temperature cools down, and as the air passes by the bigger jar, it forces the atmosphere to condensate on the inner jar of the larger jar. And then once it meets its gravity point, it will actually run down the inside of the larger jar and form on the bottom, as you can see in that footage there. So as you can see here, it was just a matter of actually taking our results and recording our results so that everyone can see. And of course, we are keeping in mind that there is a possibility that there was some leakage from either the rain that had happened being absorbed into the jar itself, or perhaps even the condensation that was forming on the outside of the jar during the night, running down off the lid and being drunk by the actual jar itself. And the reason that may be happening is, I imagine there's a pressure differential between the inside of the jar and the atmosphere on the outside. And the reason that would be was obviously because of temperature variations. So you can see here, we got nearly 150 mil out of the charcoal solar distillation unit, and that is impressive results. In fact, it was so impressive I doubted the results to begin with. So like I said, now what we need to do is actually go ahead, set these experiments up again, and we'll run them for a little bit longer this time, purely because I don't have the time to actually monitor them every 3 days. So we'll run it for 7 days or 8 days this time. We'll come back in 7 or 8 days and we'll check out to see what the results are. And purely the reason we're doing this is to take the lid off the charcoal unit, the one that we suspect could be leaking moisture into the jar, and we'll put that lid onto the standard variation. And if that lid is indeed absorbing moisture from the outside, then we should see more water in the standard variation than what we should see in the charcoal variation. But if we see that there is still way more water in the charcoal variation than the standard variation, then this is conclusive evidence that the charcoal is in fact improving the yield in the solar distillation unit of the charcoal unit itself. And that's it for today's video. If you got something of value out of this video, please feel free to give it a like. Any suggestions on ways to improve this process, please put them in the comments below. It's great that there's so much discussion about it. And until next time, thanks again. Cheers. Bye.